is 3, 15, 22. And we are doing volume. Now, volume involves three-dimensional objects, 3D objects.
X, Y, and Z.
Are we going
Yep.
to like squares or triangles?
All right. We're first going to do what is called a rectangular prism. Now, a rectangular prism, Sophia, is just a super fancy word for rectangle. But it's a 3D rectangle, like a box, like an Amazon box that you guys get in the mail. So, volume is a rectangular prism, basically. It's a 3D, okay? So, I'm going to teach you how to draw a 3D box. If you already learned from art, you know, the vanishing point, all that, awesome, cool, do it. I'm going to do it the way I find it easy to help students do it. If you have graph paper, super easy. If you don't have graph paper, you have line paper, you can still do it. It's just a little bit harder. All right, first thing is just leave some space on the top because you're going to be drawing up. Just draw me a rectangle. Doesn't matter the size. I'm not counting these boxes. Not yet. So just draw me a rectangle that looks like this. Best of your ability. If you have line paper, draw me a rectangle. No big deal. Yeah, okay. That's cool. That's cool.
It's all good. It's all good.
You know. Okay. It's all right. It's all right. Now, we're going to go from this corner up here. So start at this corner up here. If you have graph paper, follow along. Go 2 lines to the right, 1, 2, and 2 lines up, 1, 2, and put a dot. So start right here, 2 lines, 1, 2, and then 2 lines up, 1, 2, and put a dot. If you have line paper, just kind of move like your pinky over, and then to the line up, dot. So 2 and 2. Sure. Okay, now go to the other side and do the same thing. 2 boxes, 1, 2, and 2 boxes up, 1, 2, and put a dot. So 1, 2, 1, 2.
What if not line the box?
So just like your little pinky over, and then up to that next line up, or 2 lines up. Okay, you have your 2 dots. Now connect your 2 dots with a line. Okay. Now, do you remember the original corner we started with? Connect that to your original dot. Your first dot to that corner. Yep. And this corner with that dot. So that creates your top of your box.
No.
All right. Now, to the bottom, right here. From here, you're going to go 2 boxes to the right, and then 2 boxes up. 2 to the right and 2 to the top. Up and up. 2 and up. Okay? So this dot right here. 2 over and 2 up. 2 over and 2 up. So the same, we're always going to go 2 to the right and 2 up. I'm going to connect this dot to this dot. This dot to this dot. These 2 dots. Okay? And then this back, kind of like on a diagonal. This is on a diagonal. Now, what you're missing is the back of this part, this dot right here, these back dots. It doesn't really matter if you add them or not. Ta-da! It's a 3D box. Yay. They pay me to do this. Can you believe that? They pay me to do this. It's great.
Interesting.
You know? Okay.
What about the lines in the back?
Well, I dot them. You don't have to. You don't want to. All right. We're okay? Okay. So this is your first, maybe your 3D box. So volume, when we talk about volume is the quotation marks inside. Okay? How much, this is totally so math, how much stuff fits inside? I mean, this is a very, like, appropriate 7th grade definition of volume. I mean, this is like, whoa.
Wasn't this in like the 3rd grade?
Yes. Volume is the inside, how much stuff fits in the box. I don't know how else to explain it. So, I have a box here. It's heavy, I can't pick it up. So, no, I just lied to you because I would just say something randomly.
Well, that's what
Okay, so your volume is how much stuff fits in this box. So this box is full of paper. So how much paper fits in here? That's volume. How much stuff fits in the box? And this box is 3D. We can hold it. When it comes to area, it's kind of like the lid that is flat. Area, when we learned area back in the day, that's the flat part. Now volume is your 3D shape. And volume also is when we talk about a water bottle, how much water fits inside. That's volume. Volume is how much stuff fits inside, okay? If I had a cup and I filled it up with like flour to bake a cake, how much flour fits in the cup? That is when we talk about volume. How much trash fits in the trash can? That's volume. How much stuff fits inside? Does everybody understand volume? When we talk about area, it's carpet, flat stuff. Okay? All right.
There's a way to explain it because it feels like it's never explained in the real way.
I mean, I'm just trying to make it so you can make the connection. And make it more like you understand as a 7th grader, you know?
How much
What
can you fit inside of something
Huh?
that is a certain size?
like how many marbles fit in this room?
What's the size?
Brilliant.
That is volume. We can actually do it. But we don't want to. Too much time. Okay. Huh?
Can we do that?
Yeah. Maybe towards the end of the year, we'll be like, okay, everybody bring in a marble.
No,
We'll measure the marble.
10,000, so we $10,000.
Okay, so Angel's going to bring 10,000 marbles, and we're going to fill in the whole... We'll start in that back corner.
This could be math.
Put a little border on that side.
Yeah. Okay, here is the formula for volume. Volume is equal to fancy L times fancy W times fancy H. Okay, if you can't draw the fancy letters, cool, just write L, W, H. You can just write volume is equal to length times width times height. No fancy.
I drew like a
Yeah, it's cursive, but it's cool if you like don't remember cursive. It's fine. Volume is equal to length times width times height. It's okay, Santiago. All right. So, volume, this would be your length. Let's label the box. Length. This would be your width, and this would be your height. So, how tall is my box?
like 2 feet and a half.
2 feet and a half.
That's
All right.
like 5 inches.
What's the height of my box?
5 inches.
What's the width? How far does it go back? So width is how far it goes back. This way. In the classroom, this could be the length. That could be the width. And this is the height, right? Height is up and down. That's your length. How far from here?
That's about like
And then that's your width from here to here, right? Because this, what you're sitting in, is a 3D box, if you haven't noticed. That's why we can stuff this room with marbles if we wanted to. But we don't.
I want to.
All right, let's draw another rectangular prism. This one's faster, though.
Like a 3D one?
Like the other one, 3D. There. Move over and up. Move over and up. Connect. Connect, connect. Look, the good thing is I don't grade you on your ability to draw a 3D rectangle. Okay? That I do in my STEM class, because that is part of the class. In math, I'm going to grade you on the math. I'm not going to grade you on can you draw this, okay? So that's why it's like to the best of your ability, draw it. If you don't know how to draw it, don't spend more than 2 seconds on it. It's fine. I'm more worried about the math. All right. So I'm going to say that this is 6 centimeters. This is 5 centimeters. And the height is 2 centimeters. So 6 centimeters by 5 centimeters by 2 centimeters. Volume is pretty easy because all you have to do is multiply those 3 numbers and you're done. Volume is equal to length times width times height. All right, so focus. Don't. What's my length? 6. Times, what's my width?
5.
What's my height? Okay. Okay, so now multiply these 3 numbers. Guess what? You can multiply them in any order. I would do 5 times 2 first. Huh? 5 times 2?
The answer is 10. 10 times 6 equals 60.
Why did I say 5 times 2 first?
Because it's the easiest.
Because it's the easiest. What's 5 times 2?
20.
10.
Wait, what?
5 times 2.
Oh, I thought it was
5 times 2 is 10. And then 10 times 6? 60. All right, watch and be amazed. Volume is equal to 60, right? That's 5 times 2 times 6. Centimeters cubed. Oh, this is where you're supposed to be amazed?
No.
Yeah, thank you. Thank you. Thank you. Okay. How many numbers did you multiply? 3. How many centimeters did we multiply? 1, 2, 3. That's why it's centimeters cubed. Because you multiply 3 of the centimeters, it's cubed. So, when you do area, it's centimeters what? Squared. When you do volume, you do centimeters cubed. Okay? So today's the first day you learn when you use, maybe, centimeters cubed. Huh?
The answer is 3.
No, the answer is 60.
No, but centimeters.
The centimeters is cubed, not the 60. The centimeter. Why is it centimeters cubed? Because it's centimeters times, Alyssa, centimeters times centimeters. These 3 centimeters, when you put them together, become centimeters cubed. It's kind of like, what's x plus x? 2x. But this is multiplication. Don't worry too much about it. Just know, when you're doing volume, put a little 3. Got it?
Not a circle.
Oh, well, it depends.
How do you do a circle in a 3D site in a paper? You need size.
Cylinder. It's a cylinder.
Cylinder. A circle, a sphere.
Oh, a sphere is different than a cylinder. In 7th grade, we do cylinders. We don't do spheres. Spheres are in 8th grade.
Is that a square or
It's a rectangular prism again. You can do a cube. They're called cubes when it's a square.
Oh, it was 6. Oh.
Right? All right. 10 inches, 7 inches, and 3 inches. 10 inches, 7 inches, and 3 inches. So I'm asking you to find the volume. So volume is equal to length times width times height. You might get this on your map test starting on Monday. And it's a pretty easy question. When you really look at it, all I have to do is multiply these 3 numbers. 10 inches times 7 inches times 3 inches.
110 inches.
Isn't 3 inches like the side of my
Cube.
Good. That's how they'll trick you. They'll this is a different problem, but Randy, they'll do like yards, yards squared, yards cubed, and no units. And it's like, okay, I know my answer is 180, but which units do I use? That's how they'll trick you. They'll trick you on the units. So be careful. All right. What's 7 times 3? 21 times 10. So my volume is equal to 210 inches and then the little 3. Now, if you get a calculator, can you plug in 10 times 7 times 3? Yeah. But your calculator is not going to give you the units. You have to put the units. You have to know that it's inches cubed. Got it? That's the hard part. Okay, let's do a rectangular prism that's standing up.
Wait, what? How do you even write that?
So you do a skinny rectangle. Like a skyscraper building. Okay? And then I do 1 over when it's skinny. 1 over and 2 up. 1 over and 2 up. So instead of doing 2 over, I do 1 over because it's the skinny one. Isn't kids in art learning this? And then the vanishing point? So it's different.
It's just like a friendly, just go with the lines. It's just like a like because the
Yeah.
line in the side.
Because it's like in the back. You don't see the back of the box. Alright. 4 yards, 5 yards, and 9 yards. Okay. Volume equals length times width times height. Now, honestly, between you and I and YouTube right now, it doesn't really matter where you plug these numbers in. Okay? Really doesn't. Today it doesn't. And tomorrow it does, actually. So it is good habit to know that this is your length, this is your width, and obviously this is your height, right? Are you going to get the wrong answer if you plug them in a different spot? No. Tomorrow, maybe. When we do cylinders, yes. But when it's a rectangle, it's cool. It's fine. I would do 5 times 4 first. Yes, now we get 20. Now 20 times 9.
180?
Mm-hmm. 180 what? No. Yards cubed.
Oh, that.
You can call it yards cube, Ruben, or you can call it yards to the power of 3. But what we're saying is called cubed. Cubed means to the power of 3. So now you know. Because what does squared mean?
2?
To the power of 2. So squared means power of 2. Cubed means to the power of 3. Now some of you maybe have done this in Alex, and you're like, oh yeah. Maybe some of you can go home tonight and be like, oh, this is easy. I can go home and do this for Alex because it's a pretty easy thing to do. And it 100% is way easier than the stuff I've been teaching you these past couple of days. It's hard. It's okay. You should stay after school for tutoring. All right. Ooh, excuse me. Excuse me. You know, on Wednesday there's tutoring in room 39.
For you?
No. Well, I mean, for any subject. I totally messed this one up. It's alright. Yeah, there's no way to make it that better.
Wide out.
Totally. It's alright. Alright. 8 inches, 6 inches, 12 inches. Find me the volume. I like to write the formula over and over again just so it like sticks in my brain, hence 6 in your brain.
Is it 12?
Yeah, sorry. That is a 12. It's an ugly looking 12. There. Better.
Doesn't matter what we put.
Use a calculator. Kaylee, use a calculator. Go for it. You might get a calculator on these problems. What do I do with the calculator, though? I know, but the calculator doesn't know what you're solving for, Randy. Not Randy, Ruben. Use a calculator. Because even if you, you have to still know what to do with it, right? Am I adding these? Am I subtracting these? What am I doing with this? Multiplying. So take out that calculator and multiply. And then write your units. The calculator doesn't tell you the units. What happened?
We have like 3 more minutes.
So I'm getting closer to the homework. But I took a break. Sorry. You can take a break.
No, now I
Huh? Any of those 3 numbers. Okay, what do we get?
576.
What?
To the power of 3.
Inches to the power of 3, inches cubed.